two subnets are attached to the network 192.175.123.0 via router R2. The network mask for the subnets, where we can find hosts C and D, is 255, 255, 255, 224. This means that the first 3 bits in the last byte are the subnet ID. The network address of the first subnet is 122.32. The last byte looks as follows in the binary representation. The network address of the second subnet is 122.64. The last byte looks as follows in the binary representation. Which entries are required for the routing tables so that all hosts can communicate with each other and also with the Internet? Let us start again with host A. Host A can directly reach host B, router R1 and router R2. It is necessary to note in the routing table that router R2 is used to send packets to the hosts in the subnets of 122.0. This is possible via the interface of R2 with the IP address 123.4. The subnet mask is provided as 255, 255, 255, 224. It is therefore necessary to compare the first 27 bits. To get to the Internet, the packets have to be sent to 123.1, that is router R1. This is the standard router for host A. Host B gets the same routing table entries. Host C needs the following entry in its routing table so that it can communicate with other computers. The standard router is router R2, which is reachable via the interface with the IP address 122.33. The subnet mask is not considered for a standard router. All packets which cannot be delivered directly in the attached network are sent to the standard router independent from the subnet mask. Therefore, the subnet mask does not have to be provided. The standard router for host D is also the router R2. However, it is reached from host D via the interface 122.65. Router R1 can directly reach host A, B, and router R2. To be able to communicate with the hosts C and D, it has to send packets to the router R2. The routing table entries therefore are: all packets for hosts in the networks 122.32 and 122.64 are provided to router R2, which can be reached from R1 via the interface 123.4. The subnet mask determines that on data transmission, the first 27 bits are checked whether they are the same. The router R2 can directly communicate with the hosts A, B, C, and D, as well as router 1. If it wants to send data to the Internet, it has to send them to router R1. This is the standard router in the routing table.